Hello my friends, and welcome back to the You Can Do TV channel. From the hum of high-speed extrusion lines to the steady rhythm of precision twisting machines, Merladar Rope stands as a modern titan of industrial craftsmanship. Founded with a singular mission to engineer strength into every fiber, the company has grown into a global force in PP and HDPE rope manufacturing. Inside its production halls, polymer granules are transformed under controlled heat and calibrated rotational speeds into filaments of remarkable tensile power. These strands are drawn, twisted, and braided with mechanical accuracy, ensuring uniform diameter, balanced torque, and consistent weight in every coil. Built for the punishing demands of the sea, the strain of construction sites, and the relentless sun of open fields, Merladar ropes resist UV radiation, moisture, and abrasion. Their durability is not accidental. It is engineered. Export-grade logistics and meticulous documentation carry these coils of strength across Africa, the Middle East, Europe, Asia, and South America. In every shipment lies a story of precision, endurance, and industrial evolution. Starting a coconut business requires a detailed coconut selection process to ensure premium quality products. Initially, mature coconuts are harvested from the plantation. Dry coconuts are collected, and the outer husk is removed using metal spikes driven into the ground, which allows for safe and efficient dehusking. Once husked, coconuts are sorted and classified based on size, weight, and shell hardness, which directly influence product yield and quality. Farmers also assess moisture content, fiber thickness, and the condition of both the coconut water and kernel to select the best specimens. After classification, coconuts are carefully packed into sacks and loaded onto trucks for transportation to processing facilities. Proper handling during collection, dehusking, and transport is critical to preserve freshness, prevent damage, and maintain the nutritional and sensory qualities of the coconut. This technical approach ensures that only high-quality coconuts proceed to subsequent stages, such as washing, grading, and processing into coconut water, milk, oil, flour, or other value-added products, providing a strong foundation for a successful coconut business. Sri Lanka's tropical climate provides ideal growing conditions for high-quality coconuts, making the region one of the world's most recognized sources of premium raw material. At the Cocoa Ceylon Exports Facility, extra virgin coconut oil is produced exclusively from organically grown coconuts, cultivated without chemical fertilizers. Only clean, fresh, and fully mature nuts are selected to maintain strict purity standards throughout the production chain. The processing line begins with mechanical dehusking and shell removal, followed by careful separation of the inner kernel. A thin brown membrane beneath the shell is meticulously peeled away to ensure a clean white kernel surface. Skilled operators trained through internal programs handle each stage with precision. The prepared kernels are repeatedly washed to remove contaminants before passing to the shredding unit, where stainless steel cutters reduce them into uniform flakes. Moisture removal is carried out in industrial dehydrators engineered to stabilize the flakes without compromising aroma or nutrient content. Quality controllers monitor temperature, humidity, and processing time to prevent degradation. Once dehydration reaches 100% moisture elimination, the dried flakes enter the cold press extraction system. This fully enclosed press generates pure, colorless, and odor-stable organic coconut oil without exposure to excessive heat. Extracted oil is collected under hygienic conditions, sampled, and analyzed to verify clarity, acidity, microbial safety, and overall consistency. Approved batches are transferred to the packaging division, where sterilized bottles are filled and sealed under the supervision of quality assurance personnel. Each bottle undergoes visual inspection and labeling before being packed for shipment. Through this controlled and fully traceable workflow, Coco Ceylon Exports delivers organic, extra virgin coconut oil worldwide under the Cocoma brand, ensuring stable quality, safety, and freshness, from tropical plantation to final consumer. Coco Goods Company operates a technically advanced coconut processing facility in the Mekong Delta. Harvested coconuts are rapidly transported to maintain freshness and nutritional integrity. Each coconut undergoes precise sorting and quality inspection before entering automated production lines. The facility uses modern equipment for extraction, pressing, and refining to produce coconut water, coconut milk, coconut cream, extra virgin and refined coconut oils, toasted coconut chips, coconut flour, and coconut butter. Every stage follows strict food safety protocols, including International Organization for Standardization standards, hazard analysis and critical control points, and British Retail Consortium standards. Organic plantations are managed under United States Department of Agriculture and European Union organic guidelines. The integration of advanced machinery, continuous monitoring, and controlled processing ensures consistent high-quality products for global distribution under the Coco Rusco brand. Nestled in the lush southern province of Ben Tre, Vietnam, Coco Hi-Tech JSC transforms abundant coconut shells into high-quality fiber mats. Famous for its coconut groves, the region provides an endless supply of raw material, which the factory waste. The process begins with breaking the shells, separating long, soft, light brown coconut fibers. Equipped with modern machinery, the fibers are processed under strict, standardized procedures. Twisting machines then turn these fibers into coir yarn, roughly 13 to 14 millimeters thick, which is further twisted into durable coir ropes of 16 to 18 millimeters in diameter. Every stage is closely supervised by experienced employees, ensuring that each rope maintains the highest quality. From these ropes, skilled hands weave coir mats. Using hammers and precision techniques, the ropes are tightly knitted into mats, measuring 10 meters long and 35 millimeters thick. Once complete, each mat is carefully rolled and neatly packed, ready for shipment. With over a decade of experience, Coco Hi-Tech's team attends to every detail, from fiber selection to final packaging. Thanks to Ben Tre's abundant coconut resources, the factory can fulfill large orders without compromising quality. Every coir rope and mat reflects the company's commitment to excellence, durable, sustainable, and crafted with care. For those seeking top-quality coconut fiber products, Coco Hi-Tech JSC ensures reliability and consistency, making it a trusted partner in natural fiber manufacturing. Nestled in the heart of Kerala, Sulfex Mattress Factory has been crafting premium mattresses for over 25 years, blending traditional values with modern German technology. Sulfex Mattress Factory in Kerala operates with precision-engineered processes, combining modern German technology with rigorous quality control. The production begins with the collection of natural raw materials, including latex, fibers, and other components sourced from Kerala, Karnataka, and Tamil Nadu. Each material is carefully inspected for quality and then passed through a drying chamber to remove moisture at controlled temperatures. The dried fibers are processed through rope twisting machines and fiber tanks to form uniform sheets. Advanced vacuum systems remove dust, water, and residual moisture, ensuring clean and high-purity materials. Layers of latex and fibers are then assembled according to predetermined density specifications, with any material lost during pressing reapplied to maintain uniform thickness. Cutting and shaping are carried out using PLC-controlled automatic machines, allowing precise dimensions for each mattress layer. The assembled layers pass through drum presses for compression, and hydraulic presses finalize the mattress block formation. Sidewalls are reinforced with Ghani cloth and vulcanized to ensure structural integrity. Quilting machines capable of producing up to 1,000 design patterns provide uniform stitching, while tape-edge systems seal the mattress perimeter. Each mattress undergoes rigorous quality checks, including density, firmness, and dimensional accuracy, before moving to the packing section where edges are capped and the product is labeled and prepared for dispatch. The factory operates in 3 shifts, combining 50% automated operations with 50% skilled human oversight, producing up to 2,000 mattresses daily. Integrated systems for dust extraction, temperature control, and material handling optimize efficiency, reduce waste, and maintain consistent product quality across all batches. The factory runs 3 shifts, combining skilled human oversight with automated precision to produce up to 2,000 mattresses daily. Sustainability is a priority. Machines are fuel efficient, dust and water are managed carefully, and environmental cleanliness is maintained throughout. Every mattress reflects meticulous attention to detail, ensuring comfort, durability, and satisfaction for customers worldwide, a true legacy of Kerala craftsmanship meeting modern innovation. Sri Lanka's coconut triangle, raw coconut fibers, and husk chips begin an extraordinary transformation. What starts as simple agricultural byproducts is meticulously processed into high-performance materials. The production process begins with a careful collection of raw coconut materials. These are first spread out to dry uniformly under controlled conditions. Once dried, the fibers and husk chips are fed into compression machines, which densify and prepare the material for further processing. Next, the compressed material is cut and classified according to specific technical parameters to meet different application requirements. These include hydroponic growing media, greenhouse substrates, animal and pet bedding, and rooftop garden solutions. Throughout every stage, collection, drying, compression, cutting, classification, and blending, strict quality control ensures consistency, cleanliness, and performance. Sulfex Mattress, located in Coir, Kerala, India, starts by collecting coir fiber and natural latex as raw materials. The coir fiber is processed, separated and pressed, then mixed with latex to create durable, elastic, and breathable, rubberized coir sheets. At the factory, latex is prepared as a thick mixture, then sprayed evenly into the coir fiber. The Coir latex mixture is pressed and heat-treated vulcanized to fix the structure, increase durability, and elasticity. After pressing and synthesizing, the Coir latex sheets are cut to shape according to the required mattress size. Final mattresses are assembled with padding or upholstery, then inspected for consistency, density, and quality before packaging. Coconut husks are collected, cleaned, and processed into fibers called coir. These fibers are washed, dried, and sometimes compressed into mats or blocks. The coconut husks are transported using agricultural tractors equipped with front-end loader attachments. This allows efficient collection and movement of the heavy husks from the field to the processing area. Coconut coir fluffing involves loosening and separating dried coir fibers to increase volume and improve air circulation. This process ensures the fibers are light, airy, and evenly distributed, enhancing their suitability for mattresses, cushions, horticultural substrates, and other applications requiring natural resilience and cushioning. The production of cocoa coir and cocoa peat begins with collecting coconut husks. The husks are soaked and sprayed with water to soften them, then fed into grinding machines to separate the fibers from the pith. The resulting material is spread out and dried under controlled conditions to remove moisture evenly. After drying, the fibers in cocoa peat are pressed and compacted into uniform sheets or blocks. This systematic process ensures that both cocoa coir and cocoa peat are clean, consistent, and ready for applications in horticulture, hydropon. The coir mattress bare sandwich process begins with natural coir fibers, which are cleaned, softened, and rubber-coated. These layers are carefully stacked to form the mattress core, pressed for uniform thickness, and then cured to bond the coir and rubber, creating a durable, resilient, and eco-friendly mattress. Century Fiber Plates, India's leading rubberized coir producer, transforms natural coconut fiber, coir, into eco-friendly, durable mattress material. Coir is carefully combined with natural latex and vulcanized at high temperatures to create 100% natural rubberized coir sheets. This process enhances resilience, providing natural spring action, breathability, and pest resistance, making it ideal for mattresses, furniture upholstery, and baby bedding. Each batch undergoes rigorous laboratory testing to ensure quality, certification guarantee, safety, and consistency. Century's rubberized coir blends traditional coconut fiber with modern technology to deliver sustainable comfort worldwide. The journey from the rubber tree to natural rubber begins with tapping latex from Hevea brasiliensis trees. Skilled workers make precise incisions on the bark, allowing the latex to flow into collection cups. Once gathered, the latex is filtered to remove impurities such as bark and debris, ensuring a clean starting material. Next, the latex is coagulated using acids, forming solid rubber sheets. These sheets are pressed to remove excess water and achieve uniform thickness. Specialized rollers then smooth the sheets, preparing them for the drying process. Drying can be done naturally under controlled sunlight or in dedicated drying chambers with regulated temperature and airflow, which stabilizes moisture content and preserves elasticity. After drying, the sheets are graded according to quality, with defective portions removed. Final inspection ensures the mechanical properties, elasticity, and consistency of the sheets meet industrial standards. Processed natural rubber sheets are now ready for applications such as tire production, footwear, and machinery components. Spring mattresses are crafted in Plymouth, England, by a team of 130 skilled artisans using time-honored techniques combined with precise modern equipment. At the heart of each mattress lies a single, double, or triple layer of high-quality springs made in-house. Vanadium steel, superior in strength to standard steel, is coiled and cut on-site into the signature 6-turn springs. 74 different spring types allow bespoke tensioning to suit every comfort preference. Each spring is encased in a pure cotton calico pocket, free of bleach or dyes, which breathes naturally to circulate air. The pocketed springs are arranged in a honeycomb pattern and tied with natural twine, without glue, ensuring independent movement for full body support. These units may include border rods for stability and air vents for enhanced ventilation. Next, layers of natural fibers, including British fleece wool, silk, bamboo, cotton, and horsetail, are expertly hand-seated over the spring unit. Artisans meticulously tuft each mattress by hand to keep the fillings in place, creating a contoured, cloud-like surface. Side stitching is performed manually with up to 6 rows of natural twine, anchoring the honeycomb spring unit to the outer shell, a process that can take up to 8 hours per mattress. Tape edging machines then seal the borders to the top panel, ensuring smooth, raw, edge-free surfaces. Handles are double-stitched for durability, while zips are added for link or zip models. Finally, a quality inspection is conducted, tension is labeled, and a fire safety certificate is attached. The result is a fully natural, sustainably made mattress that combines handcrafted skill with engineering precision. Each Vicpring mattress offers individualized support, superior airflow, and luxurious comfort, guaranteed for 30 years, exemplifying the perfect blend of traditional craftsmanship and high-performance mattress design. Talalay latex is the gold standard in bedding materials, prized for its exceptional comfort and support. The process begins with premium natural latex, carefully prepared and mixed to ensure consistent quality. This latex is poured into precision molds and vacuum sealed to remove any air pockets, creating a uniform, buoyant structure. The molds are then frozen to stabilize the material before being gently baked in a controlled environment, which solidifies the latex while preserving its unique elasticity. After curing, each Talalay latex layer undergoes rigorous inspection, including density, resilience, and uniformity checks, ensuring every mattress or topper delivers the intended support. The result is a product that gently lifts and cushions the body, relieving pressure points, relaxing muscles, and providing a restorative sleep experience. Every detail is meticulously managed to achieve Talalay's signature feel. Factory, where innovation meets comfort. At the heart of the facility, state-of-the-art pocket spring machines quietly hum, automatically forming individual coils and encasing each in its own non-woven fabric pocket. These pockets are then seamlessly joined using ultrasonic waves, creating complete pocket spring panels, the backbone of premium mattresses. Skilled operators move attentively along the line, monitoring the process, ensuring every coil is perfectly formed and every connection flawless. From coil assembly to frame construction, and finally fabric covering, each step is executed with precision, blending automation and human oversight. The factory floor is alive with motion and purpose, as raw materials transform into structured, resilient mattress cores. Once completed, the pocket spring panels and finished mattresses move to the packaging area. Here, each product is carefully wrapped, labeled, and prepared for shipping, ensuring it arrives in perfect condition. The Bedline series, a fully automated mattress production line designed for precision, efficiency, and flexibility. Tailored to your production variables, from capacity and mattress types to factory layout and labor costs, Bedline ensures smooth, one-piece flow production. Automation minimizes handling, reduces operator fatigue, and eliminates inconsistencies in manual operations, while advanced gluing stations standardize adhesive use, delivering strong, reliable mattresses with less waste. Tape edge systems reinforce the perimeter with clean, durable stitching, giving each mattress a PO. The line integrates every step: spring assembly, quilting, foam cutting, layer stacking, gluing, covering, packing, and dispatch, all monitored through an advanced control system accessible via the internet. Statistical charts track glue consumption, layer counts, production speed. Bedline's versatility adapts to any mattress type: pillow top, Euro top, all foam, or hybrid, while supporting future upgrades, layout changes, and higher capacities. It's not just production, it's a streamlined, smart, and reliable journey from raw materials. The manufacturing complex integrates multiple advanced production lines to ensure consistent quality across its diverse mattress portfolio. The Latex mattress line operates with automated mixing, foaming, vulcanization, and curing systems, producing high-elasticity rubber cores with uniform density. The pocket spring and bonal spring lines utilize CNC coil formers, heat treatment furnaces, and ultrasonic pocketing machines to deliver durable, high-precision spring units. The polyester fiber line processes PET flakes through drying, melting, spinning, and crimping to produce resilient hollow fibers used in padding and mattress quilting. The pressed cotton mattress line employs carding machines, cross-lappers, and high-temperature pressing units to create firm, dimensionally stable panels. The sewing line is equipped with industrial multi-needle sewing machines, overlock systems, and automated border tape stations for accurate cover assembly. The quilting and embroidery line features computer-controlled quilting machines capable of producing complex patterns with high stitch consistency for premium aesthetics. The polyurethane foam mousse production line uses continuous foaming equipment, cutting machines, and curing chambers to manufacture various foam grades for comfort layers. All lines incorporate quality control checkpoints, ensuring structural integrity, hygiene, and long-term performance across every finished mattress. Of natural latex foam begins with harvesting fresh latex from Hevea rubber trees. The latex is then concentrated and mixed with stabilizers, sulfur, and other additives before air is incorporated to create a light, airy foam. This foam is poured into molds, where it is shaped into the desired mattress size. During vulcanization, heat and pressure form cross-links between rubber molecules, giving the foam its resilience and durability. After curing, the foam is carefully washed to remove impurities, dried to stabilize moisture content, and then precision cut to standard dimensions. Foam products have an open pore structure that provides good ventilation, is resistant to mold, bacteria and allergies, and provides coolness and safety for users. Latex mattress production facility is equipped with state-of-the-art machinery for processing natural rubber sap into high-performance foam cores. Raw latex undergoes precise mixing, aeration, and molding under controlled temperature and pressure to ensure uniform density and consistent elasticity. Advanced curing ovens and automated demolding systems maintain quality and reduce production variability. The plant integrates strict quality control checkpoints, including density measurement, tensile testing, and visual inspection, to guarantee durability and performance. Finished latex cores are further processed with precision cutting, layering, and assembly lines for various mattress designs. Environmentally controlled storage and handling preserve material integrity. The factory emphasizes efficiency, safety, and hygiene, producing latex mattresses that deliver optimal support, breathability, and long-term reliability. Arpico Latex Foams operates an integrated, technology-driven production system engineered to deliver consistent, fully traceable 100% natural latex components for the global bedding industry. Raw latex sourced from controlled plantation networks is stabilized, filtered, and tested at multiple stages to ensure conformity with strict physical and chemical performance benchmarks. Upon entering the manufacturing line, the compounded latex is metered into precision molds and processed through the internationally recognized Dunlop foaming method, where controlled whipping, gelling, and vulcanization create uniform cell structures and optimal material elasticity. Biomass-fired steam systems supply clean, steady thermal energy to the curing chambers, enhancing process stability and reducing environmental impact. Once demolded, each foam core undergoes an intensive multi-zone washing sequence to remove residual soaps and proteins, followed by a calibrated hot air drying stage that stabilizes moisture content and prevents dimensional drift. High-density pin core configurations, up to 18,000 perforations on queen blocks, are engineered to maximize airflow, improve heat dissipation, and ensure long-term structural resilience. Final shaping is executed through automated vertical and horizontal cutting systems that deliver precise thickness tolerances for mattresses, pillows, and continuous latex sheets. Comprehensive QC inspections verify compression properties, pin core integrity, and curing consistency before packaging. Through backward integrated plantations, advanced processing controls, and stringent quality governance, Arpico maintains its position as a leading global supplier of natural latex foam solutions tailored for premium sleep products. WG&R Mattress Factory in Two Rivers, Wisconsin, operates a streamlined, employee-owned production facility engineered for consistent quality and material efficiency. The manufacturing line incorporates automated fabric cutting, high-precision sewing systems, and controlled foam layer lamination to ensure uniform density and dimensional accuracy. Coil units sourced from regional suppliers are integrated through calibrated assembly procedures that stabilize load distribution and improve long-term durability. Hand tufting stations reinforce layer bonding, reducing material shift during lifecycle use. All foam components comply with Certipur US performance standards, while hybrid models combine pocketed coils and engineered foam structures to achieve optimized support, airflow, and pressure relief characteristics across the product range. Century Fiber Plates Private Limited employs a streamlined mattress assembly workflow designed for consistency and structural accuracy. Calibrated foam blocks, Coir sheets, or spring units are first prepared to specification through precision cutting and profiling. Layering stations then assemble comfort foams, insulation pads, and core components under controlled alignment. Adhesive application is automated to ensure uniform bonding across the full surface. Quilted panels produced on multi-needle quilting machines are aligned and stitched to the core. Upholsterers are closely monitored to ensure each finished mattress core is fitted precisely into the fabric cover. Latex Orthopedic Mattress by Armos combines natural materials and advanced technology. It features an independent spring block for optimal spinal support, layered wool, latex, and coconut coir for year-round comfort, dual firmness levels, breathable construction, and reinforced foam edges. The 21 cm mattress supports up to 120 kg per bed, with a soft cotton cover ensuring durability and aesthetic appeal. The world's largest 6-ton tire is produced through precision mixing of rubber compounds, steel and textile reinforcement assembly, tire building, molding, and vulcanization, ensuring durability and load-bearing capacity. Vispring manufactures natural luxury beds using precision-engineered processes and 100% natural, sustainable materials. Each mattress undergoes meticulous handcrafting, with every stitch and component optimized for durability and ergonomic support. Customizable configurations allow for tailored firmness, filling, and layering to meet specific customer requirements. Production emphasizes material integrity, consistent quality, and longevity, ensuring structural stability and comfort retention over decades. The integration of natural fibers and expert craftsmanship promotes superior air circulation, spinal alignment, and pressure relief. Vispring beds provide quantifiable performance in restorative sleep, combining technical excellence with sustainable, long-lasting comfort solutions. The manufacturing of pocket spring mattress coils in the U.S. relies on highly automated production lines designed for consistency, speed, and quality. It starts with high-tensile steel wire fed from a spool into a wire feeding and straightening unit, which ensures the wire is perfectly straight, free of bends, and properly tensioned before coiling. Next, an automated coiling machine winds the steel wire into individual helical springs. The machine precisely regulates coil diameter, spring height, number of turns, and tension according to mattress specification, e.g. soft, medium, firm. After coiling, each spring is transferred through a heat treatment, tempering process, stabilizing the steel's mechanical properties, elasticity, fatigue resistance, uniformity to ensure long-term durability. Once springs are tempered, each coil is individually encased in a pocket. A strip of non-woven fabric is sewn or ultrasonically sealed around each spring to form a breathable bag. This pocketing isolates each coil, allowing independent movement and eliminating metal-on-metal noise and wear. After pocketing, a fully automated spring unit assembly machine arranges pocketed springs into the mattress core layout. Springs are aligned into rows and columns, possibly with zoning. Firmer coils at edges or lumbar area, softer in shoulder/hip zones, using different coil specifications. The coils are bonded together either via ultrasonic welding or adhesive, forming a stable spring core panel. Finally, the spring cores undergo thorough quality control inspection. Automated sensors and camera systems check for defects, coil dimension deviations, fabric sealing flaws, bonding gaps, or misaligned springs. Defective units are automatically rejected. The approved coil units are then ready for integration into full mattresses, combined with comfort layers, upholstery, edge support, and top ticking, before final packaging and dispatch. This fully automated CNC-controlled process allows high throughput, hundreds to thousands of springs per hour, consistent product quality, zoning flexibility, and reduced labor costs, key to producing modern, high-quality pocket spring mattresses in the USA. Talalay Global produces premium mattresses, pillows, and toppers using a precise Talalay process. Starting with natural, biodegradable latex, the liquid is mixed, poured into molds, vacuumed, frozen, and vulcanized. Products undergo 5-stage freshwater washing, drying, and rigorous 9-point robotic testing for consistency. Hand inspections ensure quality. Talalay bedding provides superior comfort, durability, pressure relief, and is free from toxins and allergens, certified as safe for people and the environment. All manufacturing is done in the USA, supplying global retailers and manufacturers. Vida Talalay leverages nature's gift of pure natural latex, sustainably harvested from rubber trees, to create luxurious, eco-friendly comfort materials. Carefully processed into pillows, mattresses, and toppers, this latex provides soft yet supportive sleep surfaces. Each product respects human health, animal welfare, and the environment, promoting restorative sleep, optimal body support, and natural airflow for a truly healthy sleep experience. Starting with natural, biodegradable latex, the liquid is mixed, poured into molds, vacuumed, frozen, and vulcanized. Products undergo 5-stage freshwater washing, drying, and rigorous 9-point robotic testing for consistency. Hand inspections ensure quality. S&S Glove operates Vietnam's largest glove manufacturing facility, covering 16.5 hectares. The factory uses biomass-based raw materials to produce environmentally friendly gloves, significantly reducing carbon dioxide emissions. The production begins with automated feeding of raw latex into precision molds, which are cleaned and prepared for each production cycle. Hands are dipped into the molds to form gloves, then cured and vulcanized to ensure strength, elasticity, and durability. After molding, gloves pass through a series of washing, chlorination, and drying stations to remove residues and enhance comfort. Automated glove counting and inspection systems monitor every piece for defects, while a centralized control room ensures smooth operation across all production lines. Wastewater is treated and up to 50% is recycled, supporting sustainability. Finished gloves are sorted by type, medical, industrial, or food grade, and packaged in the on-site packing area. S&S Glove achieves a production rate of 42,000 gloves per hour and exports to over 30 countries worldwide, combining advanced automation, strict quality control, and sustainable practices to meet global standards. Lalin Group's glove manufacturing operations follow a fully integrated technical workflow. Latex is sourced from 17,000 acres of rubber plantations, collected under strictly controlled conditions, and processed at centrifuging plants to ensure consistent viscosity and purity. Compounded latex undergoes precise dipping in fully automated batch and chain dipping lines for both supported and unsupported gloves. Computer-controlled knitting and yarn plying produce seamless liners, while robotic dipping ensures uniform thickness. Advanced in-house laboratories conduct European Standard 374, European Standard 388, electrostatic dissipative, and American Society for Testing and Materials Testing at pre-production and post-production stages. Proprietary glove designs, such as NeoFlex, optimize air circulation, thermal regulation, and mechanical dexterity. Production lines are certified to international standards for quality and environmental sustainability, integrating automated packaging, sterilization, and microbiology monitoring to maintain high-quality, compliant gloves for industrial, medical, and retail applications. The day begins in a state-of-the-art rubber compounding plant, where precision meets performance. Every small chemical additive is carefully measured by an automatic dosing system, ensuring exact quantities for every batch. Full traceability of raw materials and meticulous process control guarantee that nothing is left to chance. Every ingredient is accounted for, every step monitored. Inside the open mixer, natural and synthetic rubbers come together with carbon black, oils, and additives. The high shear process transforms raw components into a uniform, glossy compound. Once the mixing is complete, the batch-off drying and unloading system takes over, preparing the material for the knee. Sheets of compound are rolled into continuous stripes or classic strips, ready for packaging and shipment. Throughout this journey, a wide range of quality control instruments monitors every critical parameter, ensuring the final product meets the highest standards. In the laboratory, skilled technicians put the rubber to the test, measuring traction, assessing rheology, verifying hardness, and confirming density. Each test provides insight, confirming that the compound will perform reliably in tires, seals, and countless other applications. From precise dosing to rigorous testing, every step reflects the blend of science, skill, and care that defines the rubber compounding industry, a hidden world where everyday materials are transformed into essential, high-performance products. Ever wondered what keeps an off-road vehicle gripping mud, rocks, and steep trails with unwavering confidence? It is the rugged, precision-engineered tires designed to conquer every terrain. The journey begins as rubber, fillers, carbon black, and accelerators are blended into uniform sheets in giant mixers. These sheets move through extrusion, beading, and calendaring processes. Extrusion shapes treads, sidewalls, and apexes, while steel wires coated in rubber form tire beads, securing the tire to the rim. In calendaring, fabric and steel sheets are coated with rubber and cut to create plies and breakers. On the tire building machine, components are carefully assembled into raw tires, which are then molded under heat and pressure to form their final shape and tread pattern. Each tire undergoes rigorous balance, uniformity, and visual inspections, stamped for traceability, and finally packaged for dispatch delivering. The hand-mixed tire begins with the careful mixing of raw materials to create a uniform rubber compound. Various types of rubber, special oils, carbon black, antioxidants, silica, and other additives are combined in large industrial mixers. The resulting semi-finished rubber sheets are then directed to specialized machines to form components such as sidewalls, treads, and other tire parts. These components are brought together on the tire building machine in two main stages. First, the casing, followed by the tread and belt assembly. The tread and sidewalls are carefully positioned over the belt and body plies, and all parts are pressed firmly together, producing what is known as a quote-unquote green tire. Next, the green tire moves to the vulcanization process, the final step in tire production. Inside a heated mold, the tire is inflated to press against the mold, forming the tread pattern and embossing identification information on the sidewalls. The tire cures under precise temperature, pressure, and time conditions, achieving its final shape and durability. Each finished tire undergoes thorough inspection, including visual checks, X-rays, and uniformity tests, ensuring that every hand-mixed tire meets the highest standards of quality, performance, and safety before reaching the road. Mattresses begin with natural latex, harvested as sap from rubber trees. The fresh latex is filtered to remove impurities before being mixed with stabilizers and foaming agents. The liquid latex mixture is then poured into precise molds that define the mattress shape and thickness. Once poured, the latex is baked in controlled ovens, allowing it to vulcanize and form resilient, durable foam. After cooling, the molded latex blocks are removed from the molds and trimmed to exact dimensions. Each block undergoes rigorous quality checks, including density, elasticity, and uniformity tests, ensuring that only high-performance natural latex is used in the finished mattresses. Coir utilizes advanced digital twin systems, AI-driven design, and big data simulation to produce high-performance tires, including EV and airless models. Key technologies include foam noise reduction, self-sealing K-seal, and topology-optimized eco-friendly designs. Rigorous testing ensures safety, durability, and efficiency while supporting carbon-neutral production goals by 2045. Truck and bus tires are engineered to deliver heavy-duty performance, long service life, and consistent road safety under demanding operating conditions. Each tire features a reinforced steel-belted carcass that provides exceptional load-bearing strength and resistance to deformation. The tread compound is formulated for high abrasion resistance, enabling reliable traction on highways, regional routes, and construction roads. Deep, interlocking tread blocks enhance stability, heat dissipation, and even wear across extended mileage. Sidewalls are built with multi-layer protective rubber to minimize cuts and impacts, while bead bundles ensure a secure fit on the rim. Through advanced compounding, precision curing, and rigorous quality testing, truck and bus tires deliver dependable performance for commercial fleets. Dell's tire sorting application delivers high-precision handling for modern tire production and distribution lines. The system uses robotic gantries equipped with servo-driven grippers to identify, lift, and position tires with consistent accuracy. Integrated vision sensors scan barcodes and tire geometry, enabling automatic classification by size, model, or production batch. Heavy-duty linear modules ensure smooth, vibration-free motion, even under continuous operation. The modular design allows seamless connection to upstream curing presses and downstream warehousing systems. By automating sorting, Dell improves throughput, reduces manual handling, and maintains traceability across every tire moving through the facility.